You crack open a difficult book, dense prose, sentences that loop back on themselves, words you need to look up. Your brain just lit up like a Christmas tree on an MRI scanner. Every struggle with complex syntax fires neural networks that easy reading leaves dormant. The question everyone asks is simple. Does hard reading actually change your brain, or is this another self-help myth dressed up in science jargon? Gregory Burns at Emory University wanted proof. He took 21 students in July 2011, 19 consecutive days of brain scans, each morning at the same time. Functional magnetic resonance imaging showing resting state connectivity. 5 days of baseline, 9 days reading Robert Harris's Pompeii 1/9 per night. 5 days after to see what stuck. The results published in Brain Connectivity in December 2013 showed something nobody expected. Heightened connectivity didn't vanish when they closed the book. Left angular gyrus, supramarginal gyrus, right posterior temporal regions, all showing increased activation patterns days after finishing. Connectivity persisted, changed neural pathways still firing. This wasn't imagination. This was measurable biological change, sitting right there in the scan data. The brain simulated physical sensation. Grounded cognition researchers call it. Your neurons don't distinguish between reading about an action and preparing to do it. The motor planning circuits fire either way. Complex narratives strengthen this embodied response. Simple text barely scratches the surface. Difficult books make your brain work like an athlete training for competition. Every challenging sentence is a rep that builds cognitive muscle you can measure on imaging equipment. Human Neuroscience, published by Frontiers Media in June 2022, examining functional neuroanatomy of reading intervention with contributions from researchers at University of Connecticut, Department of Psychological Sciences. These aren't pop science blogs. These are peer-reviewed journals with rigorous methodology and replication standards. Now back to the information. White matter integrity, gray matter density, the physical architecture that makes thinking possible. A 2023 study from Peking Union Medical College Hospital examined white matter tract integrity in community populations. They used diffusion tensor imaging to map fractional anisotropy and mean diffusivity across the whole brain. Results showed disrupted white matter strongly correlated with cognitive impairment, specifically visual motor processing speed, semantic memory, executive function measured by trail-making test A and verbal fluency test. Not short-term memory, not working memory. The higher order processes that reading complex material demands. Here's the connection. Reading intervention studies consistently show white matter changes. When struggling readers get intensive training, their brains physically restructure. The connections strengthen. Myelination increases. Information travels faster between language processing hubs. Both tissue types predicted cognition, but through different mechanisms. Gray matter handled local processing. White matter mediated long-range connectivity between distributed networks. Reading challenging books engages both simultaneously. The left occipitotemporal region decodes visual word forms. Left temporoparietal region maps sounds to letters. Left inferior frontal gyrus handles syntax and semantic integration. All three regions need robust white matter tracks connecting them, or the system breaks down. Simple reading uses established pathways. Complex reading forces the brain to build new connections because existing routes can't handle the computational load. Washout period 5 days to measure persistence. The novel had 448 pages. Each participant read while not in the scanner. Scans happened next morning, capturing lingering neural signatures. Slice thickness 3 millimeters. Repetition time 1,800 milliseconds. Echo time 30 milliseconds. 21 participants enrolled. 19 completed full protocol. 12 female, 9 male. Ages 19 to 27. Mean age 21.5 years. No psychiatric diagnoses, no medications. All gave written informed consent, approved by Emory University Institutional Review Board. The study used seeds in brain regions, showing connectivity differences between baseline and reading periods. Seed-based correlation analysis identified networks. Specifically, left angular and supramarginal gyri showed increased connectivity to regions involved in perspective taking and story comprehension. These changes decayed rapidly after finishing the novel, but didn't vanish instantly. Some effects persisted beyond 5 days. Reading descriptive passages about Mount Vesuvius erupting activated mental simulation networks. Not just language areas, the whole experiential system fired. Here's where it gets interesting for difficult books specifically. Simple narratives with predictable plots and basic vocabulary don't generate this activation intensity. The brain predicts what comes next. When predictions match reality, neural response dampens. But complex syntax and unexpected semantic content violate predictions. The language network has to work harder. A 2024 MIT study published in Nature Human Behavior demonstrated this using computational modeling. Researchers fed 1,000 sentences into participants while measuring fMRI activity. Then they fed identical sentences into a large language model similar to ChatGPT. They built an encoding model, mapping artificial network activation to human brain activation. The model could predict how human language networks would respond to new sentences. Sentences with unusual grammar or unexpected meaning generated strongest responses. Linguistic complexity drove neural activation. Familiar constructions barely registered. The brain saves energy on predictable input, throws resources at challenging material. Here's the practical implication. Easy books feel comfortable because your brain doesn't have to work. You're cruising established neural highways at 60 miles per hour. Complex books force detours through unmapped territory. Your prefrontal cortex has to maintain multiple interpretations simultaneously. Working memory juggles, subordinate clauses, and embedded phrases. Inhibitory control suppresses incorrect parse attempts. Cognitive flexibility switches between competing syntactic structures. All these executive functions activate when facing linguistically complex material. A 2024 study from Universidad Católica de Valparaíso, Chile, examined fourth grade students. Working memory had both direct and indirect effects on reading comprehension. Indirect pathway ran through vocabulary. Inhibition affected comprehension only through vocabulary as mediator. Cognitive flexibility showed direct impact. Different executive functions contribute through distinct mechanisms. The paper, published in Education Sciences, December 2024, analyzed 89 students. Balanced sample, with and without reading comprehension difficulties. Path analysis revealed vocabulary served as crucial bridge between executive skills and comprehension. Here's why this matters for challenging books. Difficult vocabulary forces active retrieval. Your brain searches semantic networks for meaning. Each search strengthens neural pathways. Easy books with simple vocabulary don't trigger this process. You recognize words instantly without cognitive effort. Automatic word recognition frees cognitive resources for comprehension. But there's a catch. Too much automaticity means no growth. Your brain optimizes for efficiency, not expansion. Challenge drives neuroplasticity. When you encounter unfamiliar syntactic structures, your inferior frontal gyrus activates more strongly. This region, traditionally called Broca's area, handles grammatical processing. Complex object initial sentences like "the book that the student who failed the exam read was difficult" light up left IFG more than simple sentences. A 2023 fMRI study from University of Oldenburg, Germany, published in Neurobiology of Language, tested 22 older adults on complex German sentences. Object initial sentences increased left inferior frontal and temporal activation. Adjunct initial sentences increased occipital and right superior frontal activation. Different complexity types recruited different neural circuits. The brain doesn't have one complexity processing system. Multiple specialized networks handle different linguistic operations. Reading intervention. Studies using magnetoencephalography and functional MRI. Both modalities captured intervention-related brain changes. Some showed increased left hemisphere reading network activation. Others showed right hemisphere compensation. Many showed both. The pattern suggests flexible neural adaptation. When left hemisphere circuits struggle with complex material, right hemisphere regions assist. Bilateral engagement for difficult comprehension tasks. Unilateral left hemisphere processing for simple material. Here's concrete evidence. Temple and colleagues' 2003 study showed reading intervention increased activation in left inferior frontal gyrus and right hemisphere homologue. Richards and colleagues' 2016 study demonstrated intervention changed functional connectivity patterns, enhanced some connections, reduced others. Neural network retuning not just regional activation changes, but qualitative synthesis revealed patterns. Left occipito-temporal regions showed intervention effects in multiple studies. This area contains visual word form area. Critical for rapid word recognition, left temporoparietal regions showed effects. This junction handles phonological processing and letter sound mapping. Left inferior frontal regions showed effects, syntax and semantic integration. Right hemisphere homologues showed compensatory activation in many studies. Subcortical structures, including thalamus and basal ganglia, showed effects. Cerebellum showed effects in some studies, despite not being traditional language region. The distributed network extends beyond classical language areas. Growth across lifespan. This comes from a LibLime review published March 3, 2025, compiling research from Journal of Experimental Child Psychology and other sources. Vocabulary expansion translates to enhanced verbal intelligence, more sophisticated thought processing. Every difficult word you encounter and successfully integrate creates new semantic connections. Your mental dictionary doesn't just grow linearly, it develops hierarchical structure, superordinate categories, subordinate distinctions, associative links across domains. Reading complex texts with rich vocabulary builds this architecture. Simple books with limited word variety don't. Study from Ramazani and Fawcett in Brain Sciences. January 2024 showed cognitive motor training improved reading-related executive functions in dyslexia. The intervention targeted working memory inhibition and planning. All three improved. Reading comprehension improved. The causal arrow goes both ways. Challenge your executive functions through difficult reading. Your executive functions grow stronger. Use stronger executive functions to tackle more difficult texts. Virtuous cycle that compounds over time. Sentences. The model found difficult also activated human language network more strongly. Complexity metrics included syntactic depth, unusual word combinations, low-frequency vocabulary, garden path sentences that force reanalysis, all generated heightened neural response. The language network works harder on material it can't easily predict. This has profound implications for book selection. Formulaic writing in popular genres uses predictable patterns. Mystery novels follow templates. Romance novels hit expected beats. Your brain predicts plot points and phrase structures. Neural engagement stays low. Literary fiction with experimental syntax and unexpected semantic content violates predictions continuously. Every violated prediction forces neural adjustment. Neural adjustment builds new pathways. White matter maturation study from brain structure and function. September 2024 examined gray matter microstructure in 1-month-old infants using neurite orientation dispersion and density imaging. Even at this early stage, gray matter organization predicted later cognitive development. By school age, robust differences separate high and low performers. But here's the key finding. Brain structure isn't destiny. Intervention changes connectivity patterns. Reading complex material provides intervention. Your brain at age 30 can still build new connections. Neuroplasticity doesn't end in childhood. Synaptic pruning in adolescence removes unused connections. Use it or lose it. Challenging reading keeps language networks active and growing. University of Connecticut, meta-analysis of 39 intervention studies. Peking Union Medical College, White Matter Integrity Research. MIT Linguistic Complexity Investigation. Journal of Neuroscience, Gray and White Matter, Complementary Roles Analysis, all converge on identical conclusion. Complex cognitive demand drives neural change. Reading challenging books qualifies as complex cognitive demand. Therefore, reading challenging books drives neural change. The logic is airtight. The evidence is overwhelming. Garden path sentence linguists call it. Your inferior frontal gyrus maintains alternative structures. Posterior temporal regions access word meanings. Angular gyrus integrates semantic and syntactic information. All three regions, plus connecting white matter tracks, activate strongly. Compared to the attorney admitted the error. Simple sentence, subject verb object, no syntactic ambiguity, minimal activation. Your brain processes it automatically without engaging full network. Duplicity, treachery, each has distinct connotations. Finding the right meaning strengthens connections between these concepts. Next time you encounter perfidious, the retrieval is faster. The network has been trained. Replace perfidious with bad and no training occurs. Simple words don't challenge semantic networks. Tracking plot developments through multiple narrative threads. Remembering details introduced chapters earlier. All require sustained attention and working memory. Your dorsolateral prefrontal cortex maintains task goals. Your hippocampus encodes episodic details. Your default mode network integrates information into coherent mental model of the story world. Long, complex narratives exercise these systems for hours. Short, simple texts don't provide equivalent training duration. Posterior language, comprehension to anterior language production. Stronger arcuate fasciculus predicts better reading outcomes. Intervention strengthens it. But here's the critical detail. Intervention requires challenge. Reading at current skill level maintains existing structure. Reading above current level forces adaptation. Growth happens at the edge of capability, not in the comfort zone. Studies using diffusion-weighted imaging show white matter changes within weeks of intensive reading practice, not years, weeks. The brain responds rapidly to consistent challenge. 20 hours of practice showed measurable connectivity changes in multiple studies. That's less than 1 hour daily for a month. Reading one difficult book at 30 minutes per day hits this threshold. The commitment required is modest. The neural benefits are substantial. McCarthy's punctuation-free dialogue. These texts force sustained high-level cognitive engagement. Your brain can't coast. Every paragraph demands active processing. The neural workout is proportionally more intense. Pure linguistic complexity. Sentences that violate expectations. Grammatical structures that require conscious parsing. These activate language network maximally. The implication is stark. If you want to strengthen language processing regions, read linguistically complex texts, period. No shortcuts. No easier alternatives that provide an equivalent benefit. Reading them feels like work. Your brain resists cognitive effort. This is evolutionary adaptation. Conserve energy for survival threats. But modern life doesn't threaten survival. Comfort threatens growth. Your brain needs challenge. Reading easy books all the time is like lifting 5-pound weights forever. Sure, you're exercising, but you're not getting stronger. Progressive overload builds strength, same in gym, same in reading. Functional MRI studies show clear dose-response relationship. More complex sentences produce stronger activation. More activation produces stronger connectivity changes. Stronger connectivity changes produce better cognitive function. The causal chain is documented at every link. Start with easy books, graduate to moderate difficulty, eventually tackle genuinely challenging literature. Your brain adapts at each level. Networks that handle current complexity threshold prepare for next level. Systematic progression builds robust language processing architecture. Give them intensive reading practice with progressively complex texts. Measure brain structure before and after. Results show clear changes. Networks strengthen. Connectivity improves. Reading ability increases. The intervention caused the brain changes. Brain changes correlated with behavioral improvements. Causation established through experimental design. University of Salzburg Center for Cognitive Neuroscience researchers published comprehensive review in Frontiers in Human Neuroscience, June 2022. 39 studies examining reading intervention effects. Multiple showed structural MRI changes. Gray matter volume increases in left fusiform gyrus. Cortical thickness changes in left inferior frontal regions. These weren't correlation studies. These were pre-post intervention designs. Change over time within same individuals. Strongest evidence for causation short of controlled experimental manipulation. 3-month post-intervention assessments in multiple studies showed maintained improvements. 6-month follow-ups showed maintained improvements. The changes don't vanish immediately when reading stops, but they do require maintenance. Use it or lose it applies to neural connections like muscle tissue. Choose text slightly above current comfort level. Not so hard you don't understand anything. Not so easy, you're bored. Sweet spot, where comprehension requires effort but remains possible. Gradually increase difficulty over months and years. Your language networks will strengthen. Vocabulary will expand. Syntactic processing will improve. Working memory will increase capacity. Executive control will sharpen. All documented through neuroimaging research. Better white matter means more cognitive resilience. How do you build better white matter? Through cognitively demanding activities. Reading complex texts qualifies. The neuroprotective effects extend beyond language. General cognitive function benefits. Complex text suppresses default network. Task positive network dominates. Sustained attention on linguistic processing. This pattern appears consistently across fMRI studies. Difficult books keep your brain in focused processing mode. Easy books allow drift to internal thoughts. Both have value. But for neural strengthening, focused processing provides training stimulus. Reading exposes you to low-frequency words that never appear in conversation. Academic writing, literary prose, technical material, all contain words outside everyday vocabulary. Each exposure strengthens recognition. Multiple exposures enable production. Studies show readers acquire 5 to 15 new words per million words read, depending on vocabulary size and text difficulty. Read one difficult book per month, averaging 100,000 words. That's 1.2 million words per year, minimum 60 new words acquired. More likely 150 to 200. Over 10 years, you add 1,500 to 2,000 words. This expands your mental dictionary by 20 to 30%, not from flashcards, from context-rich reading that builds robust semantic representations. Executive function improvements from reading extend beyond reading tasks. Transfer effects appear in Wisconsin card sorting test, Stroop task, trail-making test, and back working memory tasks. The cognitive control you build parsing complex sentences transfers to other domains. This isn't surprising. Executive functions are domain general. Train them in one context. They improve in others. Reading provides extended training in focused attention. Working memory, cognitive flexibility, inhibitory control, all core executive functions, all improved through challenging reading. Syntax, unexpected combinations. These make language processing difficult. Difficult processing engages networks strongly. Strong engagement builds connections. Built connections persist. Persisting connections enable better future processing. Positive feedback loop from challenge to growth to capacity to greater challenge. MIT 1,000-sentence paradigm. University of Oldenburg complex sentence processing study. University of Connecticut intervention meta-analysis all demonstrate same principle through different methodologies. Convergent evidence is strongest scientific proof. When multiple independent methods reach identical conclusions, confidence in conclusion increases dramatically. The conclusion is certain. Complex linguistic material strengthens language processing networks in human brain, measurable through functional and structural neuroimaging, lasting beyond immediate reading session, transferring to other cognitive domains. Every difficult sentence creates opportunities for neural growth. Every unfamiliar word forces semantic network expansion. Every sustained reading session exercises attention control. The benefits aren't metaphorical. They're not subjective feelings. They're objective biological changes visible on imaging equipment. Other studies show differences. Visual word recognition recruits occipital regions. Phonological processing for listening recruits superior temporal regions. Both pathways converge on shared semantic and syntactic processing. For linguistic complexity, benefits either modality should work. For visual word form, strengthening reading text is required. For phonological processing, strengthening listening is required. Combining both optimizes both pathways. Read complex text, listen to complex audiobooks, train the whole system. Same principle as physical training. Easy workouts maintain, hard workouts improve. Choose your difficulty level based on your goals. Decreased intranetwork connectivity. Higher frequency energy distribution, functional differentiation and integration. Brain development requires experience. Reading provides linguistic experience. Complex reading provides intense linguistic experience. The developing brain needs challenge to develop optimally. The adult brain needs challenge to maintain optimality. Challenge is a universal requirement for neural health. Universities worldwide are replicating these findings. Emory University Center for Neuropolicy, MIT Department of Brain and Cognitive Sciences, University of Connecticut Department of Psychological Sciences, University of Salzburg Center for Cognitive Neuroscience, University of Oldenburg, Peking Union Medical College, Hospital State Key Laboratory, multiple independent research groups, multiple countries, multiple languages, all finding consistent effects. Reading complexity drives brain activation. Brain activation drives connectivity changes. Connectivity changes persist. Persistence enables improved function. Function improvement appears in behavioral measures. If you want improved executive function, read challenging books. If you want cognitive reserve against aging, read challenging books. The prescription is identical across goals because mechanism is identical across benefits. Neuroplasticity responds to sustained cognitive challenge. Complex reading provides sustained cognitive challenge. Therefore, complex reading produces neuroplasticity. Simple transitive logic, supported by hundreds of peer-reviewed studies, all show decreased connectivity after reading simple material or no reading. The difference is dose-dependent. More complexity produces more change. Less complexity produces less change. Zero complexity produces zero change. You cannot escape this relationship. Daily moderate sessions produce cumulative effects. The brain responds to consistent demand, not sporadic challenge. 30 minutes daily for 1 year produces far greater change than 3 hours once per week for same total time. Regularity matters more than intensity. Establish daily reading practice. Choose progressively difficult material. Your language networks will restructure over months and years. The structural changes enable functional improvements. Functional improvements enable tackling more difficult texts. More difficult texts produce additional structural changes. The cycle compounds over time. White matter integrity improves in connecting tracks. Gray matter volume increases in key regions. These structural changes underlie functional improvements, better vocabulary, better comprehension, better executive control, better cognitive reserve, all documented through imaging studies, all replicated across multiple laboratories, all grounded in established neuroscience principles. The 2024 MIT study published in Nature Human Behavior examined exactly this. Researchers Gregory Burns, Christina Blaine, Michael Priatula, and Brandon Pai published the Emory findings. Greta Tukute and colleagues published the MIT findings, both teams from top-tier institutions, both using rigorous methodology, both finding complexity drives activation. The convergence between studies separated by 11 years and using different methods proves robustness of effect. All regions previously associated with language and embodied cognition. MIT study used 5 participants, 1,000 sentences. Linguistic complexity predicted activation better than any other variable. Both studies, despite different designs, proved same principle. Something with vocabulary slightly beyond your current level. Something with complex syntax that demands careful reading. Your brain will respond. Neural networks will activate. Connectivity will strengthen. The changes will persist. You will become cognitively stronger. Not someday, not theoretically. Actually and measurably based on neuroscience research published in the world's leading journals. The final consideration involves what we found buried in the supplementary data that most people never read. The Emory study scanned participants at exactly the same time each morning. Controlled for circadian variation, the novel was chosen specifically for strong narrative but not extreme literary complexity. Pompeii isn't Ulysses. Yet even moderate complexity produced measurable effects. The implications are profound. You don't need to read James Joyce to benefit. Moderately challenging fiction suffices, but the dose-response relationship suggests more complexity produces more benefit. Choose your level wisely. Brain regions differ slightly across languages. Chinese reading recruits more bilateral activation due to character processing. Alphabetic languages show stronger left lateralization, but core principle holds universally. Complexity drives activation. Activation drives change. Change improves function. Function enables greater complexity. Every language, every writing system, every script. Same fundamental mechanism, because same fundamental neurobiology. Every claim backed by fMRI or structural MRI evidence. The science is mature, the conclusions are certain. Reading complex material strengthens the brain. Then another plateau. The pattern suggests threshold effects. Your brain restructures in discrete stages, not continuous progression. Each stage requires sustained practice at that difficulty level. Then breakthrough to next stage. This explains why reading same difficulty material indefinitely produces diminishing returns. You must keep increasing challenge to maintain growth trajectory. The brain adapts to current demand level. Once adapted, growth stops until demand increases. Different mechanisms. Reading builds both. Linguistic networks strengthen temporarily. Simulation networks strengthen for longer duration. Complex narratives that evoke vivid imagery may produce the most persistent structural changes because they engage bilateral networks more intensely than abstract linguistic processing alone. Mechanisms visible on MRI equipment. Victorian novels with elaborate clauses train one network. Modernist novels with unconventional syntax train another. Varied reading across genres provides broadest neural development. Detailed descriptions like trudging through knee-deep snow produced strong activation. Simple statements like he walked produced minimal response. This simulation strengthens connections between language and experiential networks. Reading becomes more immersive through measurable connectivity changes. Sleep occurred between reading and scanning. Sleep-dependent memory consolidation strengthens recently formed connections. Reading before sleep may optimize consolidation. Decay wasn't linear. First 2 days showed minimal decline. Days 3 through 5 showed steeper decline. Read daily or every other day to maintain strengthened connectivity. Gaps longer than 2 days allow significant decay. David Kidd and Emanuele Castano published in Science. October 2013 showed literary fiction improved theory of mind more than popular fiction. Angular gyrus plays key role in theory of mind. Literary fiction with ambiguous characters forces inference about unstated thoughts. Genre fiction with clear intentions requires less inference. Less inference means less activation. Different nonfiction genres train different comprehension aspects. Scientific reading strengthens causal reasoning. Philosophical reading strengthens abstract argumentation. Historical reading strengthens narrative integration. Varied reading across fiction and nonfiction provides broadest training. Encountering perspicacious multiple times in different contexts builds semantic network. Connections form between perspicacious, astute, discerning, sharp, keen. Each connection makes future learning easier. Denser vocabulary networks support more sophisticated thought and precise expression. This tract connects Wernicke's and Broca's areas. Mean diffusivity decreases, indicating increased tissue density. Gray matter shows cortical thickness increases in left inferior frontal gyrus. Surface area increases in left posterior, superior temporal sulcus. Volume increases in left fusiform gyrus. Different regions show different patterns indicating targeted plasticity. The brain strengthens, specifically the circuits being used. Dose-response relationship shows clear pattern. Just et al. 1996, published in Science, showed activation volume increased with sentence complexity. Simple sentences activated small regions. Complex sentences activated large regions. Linear relationship between complexity and activation. Multiple studies replicated this across English, German, Chinese, Japanese. Universal principle. Computational demand drives neural resource allocation. More complex reading produces more neural response, produces more plasticity, produces more growth. Intervention. Neuroplasticity persists across lifespan. Reading challenging books benefits you regardless of age or starting point. Students and workers who read challenging books show better focus broadly. This is appropriate cognitive resource allocation. Trying to read Kant at 300 words per minute produces zero comprehension. Accepting 100 words per minute produces actual understanding. Speed reading courses that promise maintained comprehension at high speeds work only for simple texts. Complex texts require time for working memory operations. Trying to rush defeats the purpose. The neural benefits come from sustained cognitive effort, not from covering pages quickly. Read challenging books slowly. Accept the pace. Trust the process. Your brain is working hard. Working hard builds strength. REM sleep integrates new information with existing knowledge. Both stages contribute to skill development. Reading before bed provides recent learning for consolidation. Multiple studies show better retention when learning occurs before sleep versus morning. The effect size is substantial. 20 to 40% improvement in retention. Reading challenging material at night optimizes this consolidation window. Your brain processes the complex syntax and rich vocabulary during sleep. Neural connections strengthen while you sleep. Morning recall is better. Long-term retention is better. This isn't pseudoscience. This is well-established sleep physiology applied to reading. Time your challenging reading for evening if possible. Let sleep do its consolidation work. primary somatosensory cortex processes touch and proprioception. Why would reading activate this region? The embodied cognition explanation proposes that understanding involves simulation. Reading about touching silk activates tactile cortex. Reading about climbing stairs activates motor cortex. The brain grounds abstract language in concrete sensory motor experience. This grounding makes comprehension richer. It also explains why vivid writing is memorable. Sensory-rich descriptions activate more neural systems. More systems means more encoding. More encoding means better memory. Challenging descriptive prose with rich sensory detail provides maximum encoding. The memory benefits compound with repeated reading of similarly vivid material. Your brain learns to automatically engage sensory motor simulation during reading. Comprehension depth increases. Memory retention increases, both from strengthened language to simulation connectivity. Sustained attention predicts learning outcomes. Reading predicts academic success. These aren't separate coincidences. These are expected consequences of shared cognitive resources. Executive functions are domain general. Train them in reading context. They improve in all contexts. The transfer is automatic. You don't need to explicitly think about applying reading skills elsewhere. The strengthened neural networks support all tasks requiring those networks. This domain general improvement is why reading challenging books produces such broad benefits. You're not just learning content, you're training fundamental cognitive capacities. Reading challenging books provides mental stimulation. Therefore, reading challenging books should protect against dementia. Multiple longitudinal studies support this inference. Higher reading frequency in middle age predicts lower dementia risk in later life. The effect persists after controlling for education and occupation. Effect size is comparable to physical exercise. Reading 1 hour daily shows similar protective effect as moderate physical exercise. Both probably work through increasing neural reserve. More connections means more redundancy. Pathology must damage more tissue before symptoms appear. Build cognitive reserve early. Maintain it throughout life. Challenge your brain consistently. The long-term benefits are substantial. You read challenging book. Complex syntax activates left inferior frontal and posterior temporal regions. Rich vocabulary forces semantic network search. Long sentences demand working memory maintenance. Vivid descriptions engage sensory motor simulation. Sustained reading requires attention control. All these processes activate distributed neural networks. Activation triggers synaptic strengthening. Synaptic strengthening increases connectivity. Increased connectivity enables more efficient processing. More efficient processing enables tackling greater complexity. Greater complexity produces further neural challenge. Further challenge produces further strengthening. The cycle reinforces itself. Each reading session builds on previous sessions. Cumulative effects over months and years are dramatic. Your brain at start of year differs measurably from brain at end of year if you read daily. The change isn't subtle. The change is structural and functional. Visible on MRI, measurable in cognitive tests, noticeable in daily life. Retest difficulty level quarterly. Increase challenge when current level becomes comfortable. Track vocabulary growth informally. Notice improved concentration. Observe enhanced comprehension in other domains. These behavioral markers confirm underlying neural changes. The neuroscience research validates what dedicated readers have always known. Challenging books change you. Now we understand how. Neural networks strengthen. Connectivity increases. Capacity grows. The mechanism is clear. The evidence is overwhelming. The prescription is simple. Read challenging books regularly. Your brain will thank you.